Okay, density, right, in science you see these triangles. Okay, so this, if you remember the triangle, density is mass over volume. If I want the volume, it'll be mass over the density. Or if I want the mass, it's density times volume. So that little triangle there can help you in different situations. Okay, first one we got a cuboid with the dimensions, gives me the mass in kilograms. It says calculate the density and state the units. Now most densities we see are normally measured in grams per cubic centimeters. So the 1.1 kilogram, it's 1,000 grams in a kilogram. So to change that into grams, I multiply 1.1 by 1,000, and then because there's 3 noughts, the decimal point will move 3 places, 1, 2, 3 noughts in the gap, so that's 1, 1, naught, naught grams. Now the cubic centimeters is a measurement of volume, so I find the volume of the cuboid. So the volume of a cuboid is length times width times height, which is 8 times 10 times 5. I'm multiplying, I'll do the 8 5s first and then the 10 last. So 8 5s are 40 times 10 is 400, and that's cubic centimeters. So my formula is set up. I either remember the triangle at the top or just following the units. The density will be 1,100 grams over 400 cubic centimeters. There's my units, and dividing that I get an answer of 2.75 grams per cubic centimeter. Okay, second question, I got a cross section. First part, calculate the area of cross section. Okay, we can divide this up in different ways. If I break that up there into a rectangle and a right angle triangle, the area of the rectangle will be 15 times 8. That is equal to 120 square centimeters. And the area of the triangle, a triangle is, formula for that is base times height divided by 2, and in this triangle the base is the length from there to there. The 20 is all the way across. 8 is to that part, so the remaining part is 20 take away 8, which is 12. And the height of the triangle is from there to there. And again, if I look at the lengths in that direction, it's 15 all the way down, 4 to that part, so this part will be 15 take away 4, which is 11. So the triangle then is 12 times 11 divided by 2. And working that out, put 12 times 11 on the top box over 2 in the bottom, and that's 66 square centimeters. So the area cross section, the total area, are those two added together, 120 plus 66, give me 186 square centimeters. Okay, the second part, the length of the beam is 2 meters and its mass is 108 kilograms. Calculate the density of the material, and again use the clue lock, the units, grams per cubic centimeters. So I want to know how many grams there are and how many cubic centimeters there are. So cubic centimeters is a measurement of volume, and we got a cross section here. Okay, cross section. So the volume is the area of cross section times the length. So the area cross section I found in the first part is 186, and the length is 2 meters, but I got to be working in centimeters. So 2 meters is 200 centimeters. So I multiply that by 200. And that is 37,200 cubic centimeters. The top part for grams, that's the mass. I need the mass in grams. So that'll be 108, and there's 1,000 grams in a kilogram. So it's 108 times 1,000. Let's change it to grams. So that's adding 3 noughts on. Now I'm ready to substitute into the density formula. So the density is grams divided by cubic centimeters. So that's 108,000 divided by 372,000. And that's 2.903. I'll write it to 1 decimal place. That's 2.9 grams per cubic centimeters. Okay, number 3. A prism has a uniform cross section 54. So that's the area cross section already been worked out. Its length is 22.7. So density, okay, formula is there, look. That's grams divided by cubic centimeters. Square centimeters, centimeters. So if I times those together, I get cubic centimeters. Okay, which is what the formula for the volume is: area cross section times length. So that is 54 times 22.7. So that's 1225.8 cubic centimeters. The mass I need in grams. So 6.5 kilograms. So to change that to grams, remember 1,000 grams is a kilogram, so I times 6.5 by 1,000. Move the decimal 3 places over, so that's 6,500 grams. So then to get the density, grams divided by cubic centimeters, so that's 6,500 divided by 1225.8. And that's 5.30265, and that goes on away while I go to 1 decimal place again. So it's 5.3 grams per cubic centimeter. Okay, number 4, we've got a cuboid. So with the measurements of the cuboid, okay, it gives me the density this time. Grams over cubic centimeters. So the cubic centimeter is a measurement of volume. So I find the volume of the cuboid first. So the volume of the cuboid, length times width times height. So that's 5.3 times 6.7 times 13.4. That's 475.834 cubic centimeters. Now then I want the mass. Okay, so this is slightly different. I want to know how many grams there are. Okay, now then going back to the triangle. Remember the triangle, density is mass divided by volume. So because I want the mass is going to be the density times the volume. D times V, the density is 8.96 times the volume, which is 475.834, and because the density is in grams per cubic centimetre, that is going to be measured in grams. So multiply that 8.96 times 475.834, so that's 4,263.47264 grams. Going back to the question, he wants it in kilograms, so it's 1,000 grams in a kilogram, so I divide this by 1,000, so 1, 2, 3, so that's 4.263, I'll write it to one decimal place, so that's 4.3 kilograms. Okay, 3 because that 6 is 5 or more, so increase that digit by 1.